The equation of a line comes in many different forms, so we'll review one that's more familiar. Which graph shows a graph of a line with a slope of 3 and a y-intercept of -2? The familiar form, or the slope-intercept form of the equation of a line, is y equals mx plus b, where m is the slope of the line, the rise over the run, and the b value is known as the y-intercept. So if we put these two numbers together in the slope-intercept form, we get y equals 3x minus 2. Again, the m value, or the slope, is 3, and this is the rise over the run, so we can think about it as a fraction, 3 over 1. The rise is 3, the run is 1. Now let's do some process of elimination. Using the y-intercept of -2, we look at the graphs and choose which ones have a y-intercept of -2 and which ones don't. Let's try graph A using a rise and run of 3 over 1, and sure enough we get a point on a line, so it looks like the slope of that line is 3 over 1, or 3. And since it has a y-intercept of -2, that's the graph of the equation of our line. Checking the other one, the rise over the run gives us 1/3, not 3 over 1, and since our slope to begin with was 3, we needed 3 over 1. So the point slope form of the equation of a line is just a little different. It uses the slope and a given point. These will be numbers that are given to you in a problem. So you'll have a particular point on a line and the slope of the line known, and we build the equation using this formula. So of course this is going to make more sense when we look at an example. We learned that a graph of the equation of a line, we can use the slope and the y-intercept. So from when we started, you could start at the y-intercept number and use the rise over the run to get another point on the line. Using the point slope formula, we can do similar things here. We're going to locate the slope of the line here being 2, the number in front of the x values, and the point is going to be the y1 and x1 we see in the formula here, and I'm highlighting them in yellow. Well, now in green. And so I'm going to plot this point on the graph, and again I picked that point off of the equation by knowing where to look if you look at the formula and compare it to the equation we had. Using the rise over the run here to be 2, or 2 over 1, rise is 2, up 2 over 1, I can plot a series of points on my graph and sketch out this line. We notice that when we graph this line, it has a y-intercept of looks like -5. Another example here, we pick the slope right off the bat out of the equation. It's the number in front of the parentheses with the x's, and this time it's -1/4. The x-coordinate in the point is 8, and the y-coordinate here actually has to be -4, because in the formula there should be a minus sign there, and we have now a plus sign. So there was a change of numbers indicating a negative number in our coordinate. This can be a little tricky, so just pay attention to the details. Plotting this point and using the rise over the run of -1/4, we can then plot a series of extra points on our line, rising up 1, going to the left 4, and we can get the equation of our line graphed on the grid. Also, I label my line with the equation itself. In mx plus b form, we would have y equals, well, the same slope, -1/4, x, and the y-intercept -2. So the slope-intercept form of the equation of a line, or y equals mx plus b, is the most familiar. The point slope form is just a different form of the equation of a line, and there's actually another one called a standard form. These are the typical equations of a line. Let's convert between different forms. We're going to convert from point slope form, which are given, to slope-intercept form, mx plus b form, and then the standard form, the one that we don't generally use too much. So I compare the formula to the equation that I've been given, and that's going to be where I start my journey here. So first, I identify the slope of the line from this point slope form, right? So m here is the 4/5 number there, so identify the slope. 2, I want to identify the point from the point slope formula. So I look for the x1 and the y1, and here I find that them to be, the x value is 5, ooh wait, careful, negative 5, and the y value is 1. Now I'm using that, I can take this information and plug them into the y equals mx plus b form of the equation of a line. And I'm going to do that so that I can find the y-intercept and write it in slope-intercept form. So starting out with y equals mx plus b, I replace the m with the 4/5 that I know, and I'm going to replace the x and the y with coordinate that I know of a point on the line. So I'm going to use the negative 5 for x and the 1 for y. That'll allow me to solve for the b value or the y-intercept. A little multiplication of fractions here and a little moving some things around, manipulating the equation, we solve for b, and we get that to be equal to 5. So the y-intercept is 5. Y equals 4/5 x plus 5. So that's the slope-intercept form of the equation of the line. In order to do the standard form, we just have to move some things around in this equation. So what I'm going to do is I'm going to subtract 4/5 x to the other side of the equation, so I have the x and y's on one side. And then I'm just going to read off the coefficients. So the a in this case would be negative 4/5. The b value would be 1, and the c value would be 5. Standard form. We don't usually use it too much. A little more practice here. Point slope to slope intercept, something we would do more. Here we're just going to do some algebra to simplify the equation by distributing the negative 3 on the right hand side, get negative 3x plus 12, and rewriting the left hand side as it is. Next, I would want to collect like terms. In doing so, I would subtract 6 to the other side of this equation. And in doing that, I'm going to get y equals negative 3x plus 6. That's the equation of the line in slope-intercept form. If you have 2 points that live on a line only, then you can calculate the slope using this slope formula if you recall from our last lesson. y2 minus y1 over x2 minus x1 are carefully placed into this formula to give us the slope of the line. Here, we calculate the slope of the line to be, well, you can also think of this as being the rise over the run. The rise is going to be 45, the run is going to be 10. We can simplify this down by reducing it to 9/2. The slope is now 9/2. It's a fraction, but that's the m value. Plugging this into the point slope formula, we replace m with the 9/2. And now the next step is to take the coordinate point x1, y1 and plug that in as well. So the y value is 20, the x value is 10, and that gives us the point slope form of the equation of a line. So PS, point slope form, SI, slope intercept form. Two equations that look different but are exactly identical. So to get the slope intercept form, we simply just use the equation and manipulate it algebraically by doing a little distribution. We distribute the 9/2, get 9/2 x minus 9/2 times 10. That's going to give us 9/2 x minus 45. The left hand side has y minus 20, and we're going to add 20 to both sides to complete this. 9/2 x minus 25 is our mx plus b. Alright, so a little look out for some practice problems and hang in there. Please like, subscribe, and hit that notification bell for more videos.